Okay, I think we can start now. Well, first of all, welcome everyone. So today we are here with the webinar Crossplane in the Wild that together Kubermatic and Scandio we have organized. And just so you know, so first of all, the session is being recorded, and tomorrow we will send you an email also with the recording so you can watch it again. And also in case someone has not been able to attend, they will also get it. And there is the Q&A enabled, so if you have any questions, you can use it, and so there is some conversation. So now I would say we can start. So yeah, the stage is yours.
Hi, and welcome everybody to our webinar, Crossplane in the Wild today. Today, we want to give you an overview over the basic and more advanced concepts of Crossplane, and we'll show you how Crossplane is actually used based on 2 examples inspired by real-world projects. So we try to cover here a very wide range in functionality, and I hope that we can provide some valuable information for people who are completely new to Crossplane, as well as to those who are already familiar with it. So let's get started with a brief introduction. My name is Daniel, and I am a Kubernetes consultant here at Kubermatic and part of the professional services team. In my day-to-day work, I normally help customers to get started with our in-house products, Kube1 and KKP, but for more than 1 year, I'm actually part of a team who is responsible to build and maintain infrastructure as code platform with Crossplane. And before joining Kubermatic, I actually had the pleasure to work at Scandio in various positions and also for quite a long time. And therefore, I'm excited to announce one of my old colleagues as our first speaker today, Benjamin.
Hi, my name is Benjamin. I'm a cloud engineering consultant at Scandio. I've been working in consulting for nearly 3 years now. It's been a long time. And my focus is on Kubernetes, cloud native, and public cloud platforms and everything related to this kind of ecosystem. So we're doing, among other things, DevOps consulting on platform engineering consulting at Scandio, apart from other things like software consulting, agile consulting, and Atlassian services. So yeah. We will get started now with the basic things regarding Crossplane. The advanced concepts, we will talk about those later. But now the first idea is we'll take a look at how Crossplane works, what are the benefits, what is it actually, and we'll do a small example. And then we'll go into the more advanced concepts with another example. That will be Daniel's case. So let's get started. So what is Crossplane? Crossplane is an infrastructure as code tool, which basically means that you provision your infrastructure using it, and you get some kind of code artifact. You can check it into Git. You can deploy via a continuous delivery pipeline, something that's testable, that's repeatable. So it falls under the same category as Terraform and Ansible, but it's, in our opinion, a much more advanced tool with much greater use cases. It is developed by a company called Upbound. It's their only product. They develop it as an open source project, and they offer a managed service around it. And the idea is it is a framework or a meta operator which allows you to handle Crossplane providers, which are the controllers or the operators for the platforms. You will try to control using Crossplane. And the main selling point is it allows you to adopt an external system like AWS or Azure and the services and what's called resources they offer into management into the Kubernetes control plane, which comes with the usual benefits like self-healing, reconciliation, a consistent RBAC experience, and basically removes any CLI utilities from your developer's machine, and all your deployment will be done using Kubernetes on your clusters. So, architecture. The general idea is, I already dropped some of these words before. Crossplane is built around the concept of providers. A provider consists of a set of CRDs, custom resource definitions, that represent the resources this provider offers. This provider needs to be configured using a provider config, and then you can create so-called managed resources in this provider. In our case, this example is just AWS. It's really easy. We have like RDS databases, which are created as a managed resource down here in the Crossplane provider. In the Crossplane provider, we reconcile these resources against your AWS account. So they're called, this is, for example, a managed resource on the right. You define declaratively as a Kubernetes YAML file, for example, a managed resource you want to have. It maps this kind of resource into Kubernetes, so you can manage it from Kubernetes and treat it as a normal Kubernetes resource. By default, Crossplane manages these resources authoritatively. By default, we'll come to that. Most of the time, it's translatable one-to-one to the Terraform resources you might know from the provider, for example, AWS or Azure. That's there's a good reason for that, because most Crossplane providers are developed using something called Upjet, which is a code generator that allows you to create Crossplane modules from existing Terraform providers. And basically the minimal instance of things you can do with Crossplane are these managed resources. And again, they're basically everything you might find as a Terraform resource in the Terraform providers. My examples here are, for example, AWS RDS, IAM roles, AKS clusters on Azure. You can absolutely do that. Or more abstract concepts in your own infrastructure, like SQL roles. There's a provider for that. Oh yeah, providers. Providers are the things that actually install functionality in your Crossplane cluster. There are modules that add managed resources, like the concept for these managed resources, the custom resource definition, and the control loops to reconcile these resources. There's an open source SDK available to generate those from Terraform, as I told you. It's like called Upjet. There are providers available for all hyperscalers, and there are a lot of community developed providers. And a great place to start is something called the Upbound Marketplace. There are free-to-use, officially maintained providers by Upbound there. If you want to install a provider, you don't have to install something like a Helm chart. The resource on the right will basically install you the Azure provider. There's a little bit of an asterisk there. They did some changes there. How do you install a provider? But basically, this is everything you need. Now you would need to install the modules for the resource. Resource types separately, but it's not much harder. It's basically a whole bunch of these, and you're good. These providers, they can implement the control loop, but they still need to communicate with your API. So you need credentials and maybe some special setup, for example, enabling alpha flags. We'll come to that. And that's what provider configs are for. Those allow you to have multiple contexts for a single provider. For example, multiple Azure subscription, multiple AWS tenants. It's, the same thing all over again. It's basically, its main purpose is to provide credentials to the provider. And if you want to use a certain provider config, you reference that in your managed resources, and then it will be deployed using that provider config. If you omit that field, it will be just using the default provider config. Basically, everything we are talking about here are cluster resources, so they are not namespaced. So these things are all cluster are available across the whole cluster, and there's no namespacing going on here. Wouldn't make much sense, to be honest. Why would your database be namespaced? It's living in an AWS account. So yeah. Some more things to the managed resources now that we know how these things are created. Managed resources you have to create, you either create them first in Crossplane. If you initially create them, they will be created, they will be applied, they will be reconciled, and then you have them. But maybe you already have some infrastructure set up using a tool called like Terraform. or CloudFormation or any or just you've set it up using the Azure pod, and you want to import these resources. There's an easy way to do that in Crossplane. You just add this Crossplane external name annotation to your resources, and Crossplane will try to import this resource into under its own management. You can be pretty liberal with this functionality, and you basically can be pretty reckless, because Crossplane will not force the recreation of a resource if you change something about a resource, or you have some reconciliation difference that requires a redeploy. If Crossplane needs to redeploy a resource, it will ask you to delete the managed resource from your Kubernetes cluster and recreate it. That's basically their way of saying, hey, yeah, I want to make this change. And that's very helpful if you're doing like databases via Crossplane, because you probably don't want to have those recreated if you have a bad diff, since the data will be gone then. So yeah, another thing that might be interesting for production databases, for example, deletion policy, you can configure that. That basically means, do I want this resource to continue existing after my managed resource in my Kubernetes cluster is gone? Deletion policy, delete and orphan. I mean, pretty self-explanatory. It's useful for maintenance things, and if you want to protect your production resource from problems, if you mess up and accidentally delete something, that's the way to go. Oh, good, it didn't cut that. I think, yeah, no, it didn't cut that off. Very nice. The other thing is the management policy. It's an alpha feature, unfortunately, but it's still useful. And you might want to enable that. It allows you to change the source of truth for Crossplane. You might ask why that's useful. It's useful if you're developing composite resources, which is are modules of multiple resources that are templated in some form. So you might create a Kubernetes cluster using Terraform, using Kube1. You set it up, you have some subnets there, and now you want to create a EFS using Crossplane in these subnets. Well, you can either use the resource IDs that are hard-coded. For example, here you can just hard-code them into your mount target groups, or you can go and use a subnet observe-only resource in your cluster to import this resource as a Crossplane resource, but have the source of truth lie somewhere else. So Crossplane will only observe this resource. It will annotate the status field accordingly, and you can use it as a Crossplane resource, but it won't mutate the state in your actual resource in the provider. That's very helpful if you're using multiple infrastructure as code tools at the same time, and you want to have some boundary, and you need to pass some information about that across that provider boundary. So yeah, that's a thing. Again, why would we do that? There's a status field in your managed resources. The status field contains very, very many interesting informations about your resource, and it allows you to template. Crossplane allows you in a feature called composition to template these fields across resources to build some stuff like they're comparable to the Terraform modules if they say anything to you. And those are updated and reconciled continuously, which is like one of the things that makes Crossplane interesting. One other thing that makes Crossplane very interesting is if you create something like a database that will have internal credentials stored somewhere, for example, for the admin user. If you're using Terraform, you have to protect your state, you have to protect your secrets, and you have to pass them somehow into the Kubernetes cluster to your workload. Since Crossplane creates the database, it can set the database password, for example, and dump out a secret using this right connection secret ref down here to a Kubernetes secret, and then you can consume that secret in your application or in other providers to configure it. For example, in this case, the SQL provider to create databases and to create roles there. One nice thing there also is the format in which these resources are generated are pretty much consistent across providers. So if you want to use, you will always have, for example, for databases, this username field, this host field, password, and port. You can pretty much rely on it being there, and you don't have to worry about it that it will break if you switch out, for example, the backend provider, which is interesting if you have a multi-cloud use case, in which case I would be very much interested to talk to you, because that stuff's rare. That stuff's really rare. So, okay, we have infrastructure as code tools. Why is Crossplane interesting? And I'd like to look at it. Why is Terraform a little bit problematic in a Kubernetes and cloud native environment? It's okay if you have like static infrastructure that doesn't change much. For example, bootstrapping a Kubernetes cluster, that's something you probably don't touch that every day. The main problems are the secret management is a bit problematic, since you have a state that is full of very sensitive data that you have to protect. And every time you need to apply something, you need to have access to that state, like write access to that state. That's a bit problematic from a security perspective. Also, the Kubernetes and Helm providers for Terraform are not great. They are hard to use. The resource model for Terraform does not really map to Kubernetes. Again, here, incompatible resource model. You have trees of resources that get generated from, for example, operators from a single resource. Terraform can't manage those, so you might leak resources, and that's not amazing. And CRDs are hard to use. They just basically say, okay, just throw some YAML into this resource and I'll apply it. Trust me, it will be fine, which makes operators kind of hard to use. And you have to do state management. And if you have giant Terraform states, they might take a while to apply. So you have to split those Terraform states. That's work, and it's hard to do right. And if you have done it, you probably know the pain, if you have cut them wrong, and yeah. And also, if you have those cut Terraform states, you have to pass data across those states, and you probably just end up with like some stringly typed system to pass resources across these state boundaries, and you will never be able to change those in any sane way. It will always be painful. So yeah, Terraform is not really composable, especially if you're doing like Kubernetes stuff. We have a customer which wanted to remain anonymous for now. They're not doing any software development, so this is not their like core business. They're doing manufacturing. Apart from other things, they have a DevOps tool chain. They're using off-the-shelf software like JFrog Artifactory and the JFrog platform, an Atlassian stack, SonarQube, and Snyk for like code quality control. They're running on AKS, which is a Kubernetes platform, the managed Kubernetes platform of Azure. And they came to us in the beginning of, like the end of 2020 with this project, and they were like, okay, we want to move these applications from on-prem to the cloud, and we want to use Kubernetes, but we want to use managed services wherever possible. So they wanted databases not run in the Kubernetes cluster, something like, for example, the Postgres operator. They wanted to run them as Azure services to make use of like the permission management of Azure and the backup services that Azure offers. Also like blob stores and backup, so no Ceph. We just use the Azure blob store. We set it up in 2020 using Terraform. TF states were separated across application boundaries, which works fine, well enough for the initial deployment. But if you have worked with Terraform, states drift, provider APIs changes, especially in Azure. Azure's APIs are a little bit unstable and erratic. Sometimes they change. And you have to basically keep up on, otherwise you will basically have giant diffs. You have to reconcile every time you want to roll over a certificate, which is not great. We deployed Helm using the Helm provider for Terraform, which made updates just hard and unnecessarily hard in our opinion. So we talked and we saw these problems. We identified that's probably because we tried to do Terraform in an environment that doesn't really work well with Terraform, which is Kubernetes. So another solution had to be found. We had some good experiences with Argo CD in the past. So we switched over the hand application deployments from Terraform to Argo CD. That worked pretty well. That wasn't that hard. The databases, for example, will still be managed in Terraform, and you still have to pass these credentials over the boundary between Terraform and the Kubernetes cluster, which is still not great, but at least we can now update these applications a little bit more easily. And if you have ever worked with Argo CD, you know how nice it is to have like an actual diff of what your resources will change, and not like, oh, I have like this Helm diff and it should be fine if I apply it, but then you have like one flag set false and it just completely deletes your database, your integrated database. So that's not great. So yeah, that's basically what we did in the recent past. And now we're moving over these resources to Crossplane, which is like the thing we're currently working on. We want to completely deprecate the Terraform layer. We want to use it only for deploying the initial cluster. And every application layer resource, like databases, blob stores, the backups we want to have set up, that stuff should be done in Crossplane. We started already with a few applications, and it's going well so far. Problems we resolved there is this interaction of deployment. So one half is deployed with Terraform, one half is deployed with Argo CD, and then you have to put the secrets somewhere into your cluster. And also it forces us to do like good architecture and good systems design, because some dirty hacks just don't work anymore in Crossplane, since it's a little bit more limited in its templating ability than Terraform. And I don't think that's a bad thing. I think it's great. For example, we had some code there to whitelist AKS nodes on databases, which is a thing you can do if you have like static workloads and you have a static Kubernetes cluster. But it just doesn't work that way anymore in Crossplane. And it's good that way, because you probably should have done it with like private endpoints in the first place. So yeah, that's great. And also we are building composite resources for databases which are already annotated with, for example, the tags needed for this Azure subscription. They come with like integrated backup. They create these databases internally, since Azure, for example, doesn't want to manage the databases and roles in your managed database. They just want they give you an admin password and be like, okay, the rest is your problem, provision it yourself. And we want to do credential management using Crossplane generated passwords. And we're already using Bitnami seed secrets and Azure key vaults for secrets we have to import from an external source. So yeah, that was basically my thing. It was a bit of a basic use case, but yeah. Now I'll hand off to Daniel, and the stage is yours.
Thank you very much. Now, I hope you can see my screen. Perfect. Okie doke. Thank you, Benjamin. Now that we covered the basics, let's take a look at the more advanced concepts in Crossplane. So if we stick to the comparison with Terraform, you might know or may have already experienced it that at some point you won't start your Terraform configuration from scratch over and over again, right? You won't write the same combination of VPC, subnet, EC2 instance, load balancer, and so on for the thousandth time. But instead, you ideally start to bundle this frequently used resources into reusable and configurable Terraform modules. And in my opinion, this is one of the strengths of Terraform, to build your own opinionated and higher level abstraction of infrastructure based on whatever resources are provided by existing Terraform providers. And also based on whatever existing Terraform modules. And Crossplane provides you the very same functionality here, to build your own opinionated higher level APIs in Kubernetes. However, if you look at Crossplane, there is no single concept of a module, but rather the different pieces, the input variables, the output variables, and the definition of the resources that you want to create are represented by 4 different API resources in your Kubernetes cluster. So to give you a high-level overview of the different components, let's take a look at this simple example. We see our developer on the very left side who wants to deploy an application along with the database instance into an existing Kubernetes cluster. At the top, we have our platform engineer who is responsible to provide this exact functionality, to provision databases just on demand. So how does this look like with Crossplane? First of all, the platform engineer has to define a certain schema or the input variables that can be configured by a developer to influence certain aspects of the database instance here. For example, the allocated disk size, the available amount of CPU and memory. And this can be done by a so-called composite resource definition, or XRD in short. Crossplane takes this XRD, copies your defined schema or the input variables, and creates 2 distinct Kubernetes CRDs, custom resource definitions out of it, the so-called claim and composite resource. You can think of the claim as your public API that is intended to be used by your developers to request infrastructure, and the composite resource as your private API that is intended for you as a platform engineer. So we still need a way somehow to define what actually happens at runtime. What happens if somebody creates a database instance? And this is where compositions come into play. With compositions, you can exactly define which managed resources are created and how the values are passed down from the developer to the actual managed resources. So if we want to draw an analogy to Terraform here, once more, you could think of the composite resource definition as your input and output variables that you define in the Terraform module. And the composition is very similar to your main Terraform configuration file where you define all your resources that you want to create. However, for the claim and the composite resource, we do not have a real one-to-one mapping, or at least not a really good one. And you might even ask yourself, why the heck do we have 2 custom resource definitions? We already define our own API with the composite resource definition. So there are 2 important differences here between the claim and the composite resource that I would like to highlight. The most important one is claims are namespace scope, while composite resources are cluster scope resources. This means that we can grant access to our own custom API at the namespace level rather than granting the developer access to some cluster scope resource. So we can introduce a real strong separation of concern here. And the second difference is the claim itself only holds a reference to the corresponding composite resource, while the composite resource holds the reference to all the underlying managed resources here. And that means we can hide the whole underlying complexity from the user. He only sees, I have a claim and the corresponding composite resource here. So now that we have a rough idea how things work together in Crossplane, I would like to highlight at least 2 of these resources, since I don't want to bore you to death with staring at YAML manifests. However, I will concentrate on the 2 most important resources here, the composite resource definition and the composition. So as I just explained, the very first thing that you have to do in order to provide your own custom API with Crossplane is to define a composite resource definition. And if you are already with Kubernetes CRDs, you will see that an XRD is quite similar to an CRD. We can define our very own custom API group and the name of the claim and the composite resource. And additionally, we can provide our schema, how our API looks like. For example, this is a very, very simple of our own custom PostgreSQL instance API. And the developer is only allowed to set the desired disk size with the field spec parameters storage GP. Nothing more, nothing less. All the underlying complexity is hidden away by the composition. So these fields are common for CRDs as well as for XRDs. However, there's also one field that is specific to Crossplane that I would like to highlight. As Benjamin already mentioned, managed resources also create so-called connection secrets. And if you think about a database instance, you not only need a way to pass values from the developer to the database instance, but we also need a way to propagate information back to our developer. Without the knowledge of the host name, the username, and the password, the developer cannot make use of the newly created instance. And by default, Crossplane will create a secret containing exactly the fields that you define in your composite resource definition. Now that we have shaped our own API, we can go on and implement the composition. So what should happen at runtime? For this, we first have to define which composite resource we are compatible with and the list of resources that we want to create. For example, here, this very simple implementation also of a PostgreSQL instance creates a single managed resource using the provider GCP. However, the composition can create as many resources as necessary. Now we see we have only static values here. However, we can apply patches to the managed resources to really use the values defined by your developer and set certain fields of the managed resource. Going back to the example of the composite resource definition, we copy the field spec parameters storage GP defined by your developer to the underlying managed resource and set the corresponding field of it. So since compositions and especially patches are the resources that you will work the most with, let's take a closer look at patches. So in general, the patches are quite simple and we have a couple of different types of patches available. So we can patch values from our composite resource to managed resources, or we can provide also values from the managed resource back to the composite resource. We can define our source and target field and can also apply some transformation before copying the value. For example, we can multiply the desired disk size here, or we can format strings. And I would like to highlight two important facts about patches here. First, patches can only copy values between, that's wrong actually in the presentation, between composite resource and managed resource. For example, if you create a VPC and subnet within the same composition, you cannot just access the values in the VPC in your subnets, for example, the VPC ID. In order to achieve or to retrieve the VPC ID, you would to copy the VPC ID back to the composite resource, and then from the composite resource again into your managed resource. And the second important fact is that patches are optional by default, which means even if the patch fails for some reason, for example, the field specified in the from field path is not available, Crossplane will still render the managed resource and apply it to your cluster. If later on the value gets available, it will copy the value, but this is important to know. However, you have the possibility to influence the behavior here and can set a desired policy. So you can make a patch required. So I hope I didn't overwhelm you with all the YAML stuff here, and you are still with me so we can talk about our second use case here, to build a central infrastructure as code platform with Crossplane. So based on what you have seen, you know that Crossplane is quite powerful. We can define our own custom APIs. We can compositions to create a bundle of managed resources that we create. So you would think, okay, building a central platform would be quite easy. We just install Crossplane in some Kubernetes cluster. We write our XRDs and compositions, and we are done, right? Well, in theory, this might sound that easy. However, in reality, there is way, way more to it if you want to provide such a platform at scale. But let's take a look at the requirements that we faced here. So one of the first key requirements was that the platform must be extensible. We didn't want to bind ourselves to only one cloud provider and have an easy way to integrate already existing services. And that's actually pretty easy because Crossplane got us covered here. As we have seen, we can use XRDs, compositions, and any of the existing Crossplane providers to build our own API without writing actually any code. And even if there is a need to integrate any existing service, as long as there is any kind of API provided by this service, we can still use Crossplane and implement our own provider. However, if we look at the other two requirements, they are way different problems to tackle. If you think about Crossplane, you will handle a lot of sensitive data and credentials. You have to define the access keys for each one of the different Crossplane providers or cloud providers, and each provisioned resource may eventually create a Kubernetes secret containing the connection details. So a strong isolation model is crucial to provide a secure platform. It helps you to prevent potential security breaches or unauthorized access to infrastructure and ensures a strong separation between the different teams. And at the very same time, we had to think about the scalability of the platform right from the beginning, because at the moment, Crossplane itself and also all Crossplane providers can only be scaled vertically by providing more CPU and memory. And for sure, we can run more instances of a given Crossplane provider, but the actual workload will not be distributed across the different instances. And if you want to run such a platform at a company level with thousands of users, you will eventually hit a limit. So it's important to keep this in mind and implement a way that your platform can scale with a growing amount of users. So while there is no single right way to implement such a platform and achieve this level of multi-tenancy, I would like to show you 3 possible solutions or architectures how you can provide an infrastructure as code platform at this scale. So the easiest way to achieve multi-tenancy in Kubernetes are namespaces. So one naive solution would be exactly the approach that I just explained in the previous slide. We use a single Kubernetes cluster, we install Crossplane along with all the required providers, and we write our own XRDs compositions. And this also has a couple of advantages. We have to maintain only a single Kubernetes cluster and also only a single Crossplane instance. We can manage this all from a central place, so the operational overhead is quite small. Also, if you recall the slides before, planes are namespace scope. So we could just provide each team with a dedicated namespace to isolate them. However, namespaces are not secure by default. In order to really ensure a strong separation of the teams or the namespaces in this case, we need to set up additional resources, airbag roles, bindings, quotas, network policies, and so on. So in reality, it's not only a namespace that we have to create here. Furthermore, since all teams share a single cluster and the custom resource definitions are, for example, a cluster scope, they are all bound to the same Kubernetes version, they are all bound to the same Crossplane version, and they are all bound to the same Crossplane provider versions. So I think the next logical step would be, okay, what about we provide each team with its own Kubernetes cluster, right? So this way we can guarantee a complete separation of the different teams as they share nothing. Everybody can choose the Kubernetes version they want, they can install the Crossplane providers they need, and everybody's happy. However, if we take a look at the pros and cons here, we just flip them. So instead of just creating some resources within a single Kubernetes cluster, we have to spin up a dedicated Kubernetes cluster for each team, which is compared to just creating a couple of resources way slower. Also, depending on how you provide this Kubernetes cluster, this could become quite expensive if you spin up a dedicated AWS EKS cluster for each team. But most importantly, we did lose the ability to centrally manage all these clusters and all these Crossplane instances. So while we now have the strongest isolation guarantees that we can provide, we need to find a way to regain the control to be able to manage all these things again. So the idea would be here, what if we introduce a central component here that is capable of managing all these clusters, all these Crossplane instances? We could, for example, just use Argo CD or Flux or any tool of your liking to deploy Crossplane to already existing Kubernetes clusters. But what if we leverage the capabilities of Crossplane here to define our own platform API? This means, why don't we just model our own account API in this case that creates the necessary resources? And this is exactly the idea that I want to show you today. So what do we need if we want to implement such a platform API? What we need is some way to dynamically spin up Kubernetes clusters. There are already example manifests to spin up, for example, AWS EKS clusters on demand with Crossplane, as well as GCP. However, for the sake of a demo today, I want to stick with KKP in this case. For the people not familiar with KKP, I just want to highlight two important features. So KKP is our Kubermatic Kubernetes platform, which is capable of creating Kubernetes clusters on demand and managing the whole life cycle across different cloud providers. So the idea here is that we can create Kubernetes clusters dynamically with KKP, either via UI or, which is more relevant in this case, with Kubernetes resources. So that means we can just create a Kubernetes cluster object within KKP. So we can leverage the existing provider Kubernetes in this case to provide a dedicated control plane for each team. The second thing that we have to provide is the Crossplane installation itself. And that's also quite easy in this case because Crossplane offers a Helm chart. So we can just reuse the provider Helm and the corresponding Crossplane Helm chart to really manage all Crossplane instances across all our teams. And finally, there's also a very neat feature within KKP. If you think about Crossplane, you also want to provide the ability to your teams that they can install the custom APIs that you develop. And we provide a very simple way to install applications within KKP. So you could use this feature to implement some kind of marketplace to provide existing APIs that you developed to the teams. And that's exactly what I would like to show you. So I hope you can see my screen and VS Code on the left side and the dashboard of KKP on the right side. So before we get started and look into the different resources, let me create such a platform account already in my cluster because it takes around 5 minutes. So while we are waiting until our account, in fact, our Kubernetes cluster and the Crossplane installation is ready, let's take a look at our Crossplane resources here. This is our composite resource definition of a platform account in our case, and we really define a very, very simple schema here. The only thing that we need to set is some kind of owner with the name and the email address. That's it, nothing more. So in order to implement the actual logic, we leverage a composition here. And in fact, we create 3 different resources here. A Kubernetes cluster within KKP. We have to provide a provider config for the Helm provider, so we can use the provider Helm to install Crossplane in the newly created Kubernetes cluster and the actual Crossplane Helm release. So as I said before, the idea here is to leverage the existing Kubernetes Crossplane provider to create a cluster object in our KKP installation. And all these values are predefined by you, the platform engineer. For example, I define a specific location the cluster should be created in. I want to create it in AWS and can set any property that is offered by this cluster CRD. Now, in the background, if we create such a cluster, KKP will create a dedicated namespace and also create a secret containing the kubeconfig in order to access the cluster. And we once more leverage the provider Kubernetes to read in the secret and use it in our provider config for the Helm provider. So now that we are able to access the newly created cluster with our provider Helm, we just have to create another managed resource here. This is a Helm release of the provider Helm based on the existing Crossplane Helm chart. So let's take a look at our cluster. It's almost up and running. We are only waiting for etcd. While we are still waiting, I already fetched our kubeconfig, and let's see if we are able to access it already. It seems so. Unfortunately, it seems the demo god is not with me, and it takes all longer than expected, but trust me, it worked 1 hour ago. So essentially what we would see is that our control plane gets ready, we get a worker node, and Crossplane will take care of installing Crossplane by itself. So instead of waiting for this to be finished, let's move on, and believe me, this worked just half an hour ago. So now that we have seen that Crossplane is actually really, really powerful in most cases, there are also a couple of crazy things that you should be aware of. For example, if you start just starting with Crossplane, or if you are already using Crossplane. One of the most discussed GitHub issues is the sheer amount of CRDs installed by some of the Crossplane providers. For example, if you want to leverage all 3 of the biggest cloud providers, you would end up with almost 2,000. You will end up with almost 2,000 CRDs within your Kubernetes clusters. And while the recommended numbers for pods, nodes, containers within a Kubernetes cluster are well known, the number of CRDs had a dramatic effect here. So if you read through the existing GitHub issues, you will read stories ranging from just increased CPU and memory load on the control plane to a complete outage for more than 50 minutes. So you could really screw up your Kubernetes cluster by just installing a couple of Crossplane providers. However, Upbound worked really hard to improve the situation and also incorporated some improvements in Kubernetes itself, which they provided upstream. So it is advisable to use at least Kubernetes 1.25 on you. The second solution here is it was just released or implemented 4 weeks ago to use the so-called provider families. Now, Upbound changed the way how the providers are bundled. Previously, you had only one provider, AWS, who provides you access to all the services that AWS has to offer. But now they split one monolithic provider into smaller pieces. For example, there's now on provider AWS EC2, on provider AWS EAM, and you can only pull in the providers or the resources that we actually need. And that's the real game changer. The second issue I would like to highlight is not really an issue, but works as intended. The fact is that patches are very simple. You can copy values from your composite resource to your managed resource and back, but nothing more. You have no loops, no conditionals, and no advanced logic, for example, to generate a random password if the user did not provide one. And there is a solution which is alpha since Crossplane 1.11. They introduced the concept of composition functions here, which means in addition to the patches within a composition, you can define a composition function which is essentially a containerized function that takes the observed state of all the resources in a composition. They will be fed to your containerized function on standard in, and you can do whatever you want with these resources and provide your desired state on the output. So this is really, really powerful, and I'm excited to see what they will add to this feature once it becomes better or stable. And the last issue here is Crossplane has no ability to define dependencies. And if you are familiar with Terraform, you know that you can define dependencies between resources. Terraform in turn will calculate a dependency tree and will create and delete the resources in this specific order. However, this is not the case for Crossplane. If you, for example, create 4 or 5 resources within a composition, they will be applied to the cluster at the very same time. And when it comes to the creation, this is not a problem. Eventually, if a field is missing, the resource will stay in a not ready state, but eventually will become ready. However, the problem becomes more imminent if you think about the deletion. If you think about the account API that I just showed you, we create a Kubernetes cluster and at the same time install an Helm release within this Kubernetes cluster. If we delete this account, both the cluster and the Helm release will be deleted at the same time. And if for some unforeseen reason the cluster will be deleted before the Helm chart, Crossplane is no longer able to check the status of the Helm release. So you will end up with stale resources in your Kubernetes cluster. But it can also turn out the other way around, that, for example, you create cloud resources, which will cost you money. And they are deleted in your Kubernetes cluster, but it still exists in the cloud. And that's a real problem. So currently, there are some situations and some workarounds. However, there's no generic solution up until now. There exists a proposal to introduce a generic usage type to enforce the order deletion. But up until then, you should be careful and test if the deletion works as expected. So now there are a couple of crazy things that you have to know if you work with Crossplane, but I think there are many, many good things. So if you ask yourself, is this a real step forward in infrastructure provisioning? At least from my point of view, I would say definitely. We narrowed the gap between the workloads that run in the Kubernetes cluster and the infrastructure. You no longer have to rely on some external process on Terraform that runs outside of your cluster to provision your infrastructure. We also have a common framework to define our infrastructure. We don't have to rely on cloud-specific operators to build our infrastructure or to use all the services that we need. And we not only benefit from the Kubernetes built-in functionality here, the continuous reconciliation, but we can use all tools that are offered by the Kubernetes ecosystem. We can use Argo CD or Flux to manage our infrastructure the GitOps way. We can use Kyverno and the Open Policy Agent to implement some policies to our infrastructure. And that's really, really powerful. But are we there yet? Is this the end? Have we achieved everything that we want to? I would say definitely not. Because while I have a strong opinion that providing each team a dedicated control plane for Crossplane, I think that's right. But you still have to provide a full-blown API server or full-blown Kubernetes cluster here. And I think eventually it would make sense to provide a more specialized control plane in this case. And there is a lot of movement in this area right now. And also, if you think about the Crossplane installation, for sure, we can manage a core Crossplane installation centrally, but the users must be still aware of the concepts in Crossplane. And in my opinion, we need still to do a little bit of work to make APIs or services, external services, consumable as plain APIs within Kubernetes. However, Upbound has done a very great job so far with Crossplane, and I'm really excited to see what features they will provide next. And that's it with our presentation. Any questions so far from your side?
I see we have a raised hand, so I will let them speak for.
Sure, please.
For Little Niemi. You can talk, we'll hear you.
Hiro? You're still muted.
Yeah.
Sorry, it was a misclick.
Don't worry, all good. Hi. So I guess the raised hand was a misclick.
Yeah.
Okay. So if there are no questions, I would thank you for attending the webinar. I hope we could provide some insights how Crossplane works, how Crossplane can use to move your existing infrastructure managed by Terraform to a cloud-native stack with Kubernetes and Crossplane, and how it can be used to build your very, very own control plane. Thank you very much and have a nice day.
Thank you. Bye.
Bye.
Bye.